Eventually, anybody will be able to expose telemetry, metrics, traces, logs via OpenTelemetry. And so when you're building an application, you could actually provide all that instrumentation yourself.
This is DevOps Paradox, episode number 151. What is OpenTelemetry? Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. OpenTelemetry seems to have almost maybe jumped the shark, or we're going to start singing the Baby Shark song. I'm not sure which one the shark is today. But OpenTelemetry is appearing to show up everywhere.
It became a thing extremely fast and forced almost I'm using the word forced. Many people were not forced, but you can say that to adapt their solutions to use OpenTelemetry, which kind of levels the playing field in a way. I mean, it doesn't level it, but at least makes users' lives much easier, less locked.
Today we have a guest on with us. We have Ramon on from Timescale. Ramon, thanks for joining us.
Yeah, thanks. Thanks for having me.
Now, why don't you take a moment and introduce yourself better than me just saying, hey, here's Ramon, and explain a little bit about what you do and really where you're seeing this whole OpenTelemetry and everything else. Where is all of this going in 2022?
Sure. So, so my name is Ramon Guiu. I lived in beautiful Barcelona. I work for a company called Timescale. Timescale builds an open source time series database called Timescale DB. And I joined Timescale about 6 months ago to help the company build a vertical solution for observability on top of Timescale DB. So Timescale DB, as I said, is focused on time series data. So this is data that has a timestamp that is changing over time, if you want. Observability is a big source of time series data. Before, and the product that I'm working on, that I'm building with the team, is named PromScale, and it's also open source. You can find it on GitHub. Prior to Timescale, I worked for 4.5 years at New Relic. I joined initially to work on their infrastructure monitoring product that was just launched when I joined them as a product manager. Eventually end up leading a cross-functional team of engineers, product managers, designers, and product marketers, building and taking to market New Relic infrastructure. And in my last year at New Relic, I worked on the data collection components, all the different agents, integrations to collect data from applications and infrastructure and send it to New Relic's backend. And so at that time is when I became very, very close to OpenTelemetry. We started aligning and working on building or moving all New Relic's instrumentation to be OpenTelemetry based. And you'll say, why? It's something that you want to do this. So a few things I'll say about OpenTelemetry for people that are not familiar with, maybe a very short introduction. OpenTelemetry is a new standard, by the way. It's backed by CNCF, by the Cloud Native Computing Foundation. And it provides a set of tools, libraries, SDKs to help engineers, to help development teams instrument their applications, their services. And also, to be honest, as well, infrastructure now too. But it's very mostly focused on the application layer. What's unique about OpenTelemetry, and it's something that hasn't really been done before, is that it defines a vendor-agnostic standard for metrics, traces, and logs, so the three main telemetry data signals that people use in observability, provides implementations for those. Like there is a reference implementation for the SDK to do manual instrumentation. There are also auto instrumentation libraries that do collect, at the moment, tracing data. So you don't have to instrument your services yourself. You can use them and get instrumentation out of the box like you would get with high-end, if you want, cloud solutions like Datadog or New Relic. And the thing that is really, really interesting is it has the backing pretty much every observability vendor in this space, as well as all cloud providers. And that is actually really important because that momentum is helping OpenTelemetry become, a real standard that is actually used, not just standard that, it's on the shelf, but that people are actually using. So as an example, AWS is standardizing their telemetry, the telemetry they generate from their services, so that people can, understand how they're performing using OpenTelemetry. So that would be an example. Splunk, for example, is, all their observability solutions are now based, on OpenTelemetry instrumentation. New Relic is going, through the same transition. And so all that momentum has made, it's quite impressive, has made OpenTelemetry the second most active project and the second project with most contributors across all CNCF projects, all Cloud Native Computing Foundation projects. Only after Kubernetes, that is obviously, big monster with a lot of people behind. But it's a pretty amazing fit if you think about it. This is instrumentation. I don't think instrumentation is not a very exciting thing, when you think about it. It's something that you have to do. You have to collect that telemetry to then do interesting things with it, analyze it, maybe drive some behaviors in the system. But it's pretty amazing that, and it is a testament of the big support and demand, that there is in the industry for a standard for instrumentation, that it has become the second most active project and with most contributors across all CNCF projects.
That kind of makes sense. I guess that I'm guessing that a big reason for that would be because so many software vendors are on board on that project. Like just as Kubernetes, it's not only about direct users contributing, individuals, but it's massive amount of companies having interest in maintaining Kubernetes and shaping it, right? I'm guessing it's similar thing happening with OpenTelemetry, right?
Yeah, I think something to keep in mind is that, for a long time, instrumentation coverage, especially on the application side, instrumentation of different frameworks, has something that has been used as a differentiator in the space. Like New Relic, for example, was probably the first, most well-known, maybe the first, I think, SaaS solution for application performance monitoring. One of the things they did really well is they had a number of agents that would auto-instrument your application. So you didn't really need, I actually, before New Relic, I came to learn New Relic because in my previous company, we're having performance problems. And so in order to understand what the problems were, I found that this New Relic thing, I logged in, I signed up, download an agent, just dropped it. It was a Java application, just dropped that jar into our web server, which was Tomcat. And all of a sudden, I started getting it was auto-instrumenting the entire application. And so what New Relic was doing is like a lot of work to inject bytecode when the different classes were loaded. So it added auto-instrumentation. It injected code to instrument those libraries. And so for quite some time, that breadth of coverage became a differentiator, because obviously you have to go, you want to instrument your applications. You don't want to have to do all the effort yourself. You'd rather use something that does it for you. And so that was one of the differentiators for some time. But over time, there has been a transition where what to do with the data, the analysis on the data is becoming more and more valuable, as well as more vendors, if you want, having a breadth, significant breadth of instrumentation. And so the problem is that the differentiator is no longer, on the instrumentation side. That's just a price that you have to pay to play in the game. It's a lot more interesting, and what people are mostly interested in is what you can do with that data. So building instrumentation, like basically redoing the same thing, each vendor redoing the same thing, is not a very efficient use of engineering resources. So this is an area definitely where I think it's an area where you can build a lot of differentiation over time. And it's definitely an area that it's better served by a collaborative effort to provide, instrumentation from, hopefully, all frameworks and technologies that are out there. The other thing important here that I mentioned is that you had to actually, as a developer of instrumentation at one of those observability vendors, you had to understand, investigate the frameworks and then see how to inject instrumentation into those frameworks. You're not an expert in the framework, like the developers of the framework are the experts. And so OpenTelemetry is dramatically going to change the model, or that's the expectation. I think it's a good path to do that, where instrumentation, rather than being baked after the fact and added after the fact by some tool, will be baked into the libraries themselves. Like developers themselves will have an incentive to instrument their frameworks. Those that create frameworks and libraries for others to use will have an incentive, because if their libraries are not instrumented, engineers will probably prefer to use others that are, because if there are problems, those other libraries give them better visibility into what's going on, so they can troubleshoot problems faster in production. So that is the holy grail of instrumentation on the OpenTelemetry, for OpenTelemetry, is that the instrumentation is baked in, is added directly in the libraries that you use, versus having something outside that goes in and tries to figure out where to add instrumentation and give you visibility.
And I guess that does not apply only to libraries, that applies to third-party apps as well, right? Whatever you run now in, let's say, Kubernetes is already likely instrumented and providing metrics that you can just pick up, right, with the tool.
So I'd say OpenTelemetry Display, I think it has existed for more than 2 years now. I think it was born a couple of years ago. But I think there is still ways to go in adoption. I think on the implementation side, there is a lot of progress that has been made. And so the tracing implementation is stable, and you have auto-instrumentation for traces for a lot of libraries. Metrics, the metrics spec became stable at the end of last year. And, there are different language SIGs are catching up on implementing support for metrics. But you're totally right. Eventually, anybody will be able to expose telemetry, metrics, traces, logs via OpenTelemetry. And so when you're building an application, you could actually provide all that instrumentation yourselves. An example, Kubernetes itself is already starting to add OpenTelemetry instrumentation into their components, so that you can understand how Kubernetes itself is performing.
Because Kubernetes right now is providing metrics all in PROM format, right?
Yeah, that's correct. I mean, there may be some exceptions, but all Kubernetes components are instrumented with Prometheus or sort of open metrics type of standard. So it's they're exposing a bunch of metrics in the Prometheus exposition format that Prometheus, that's why Prometheus has become a great monitoring tool for Kubernetes, is that you just drop in and it automatically discovers all those endpoints that it needs to scrape for Prometheus metrics and makes them available within Prometheus and in Grafana, for creating your dashboards and alerts.
So what is now then the differentiator between different metrics storages or time series databases or whatever they are? Where do they compete between each other? I mean, I guess OpenTelemetry removed some of the competition, right?
So first is that if you think about differentiating at the data layer, so there was differentiation, as I said, there was differentiation at the instrumentation layer. So that is going to disappear, okay? And it has somewhat disappeared already, but it's still, there are some differences there, but that will disappear over time with OpenTelemetry. On the data layer, the main advantages are going to be around the efficiency of the data layer, how expensive, if you want, in terms of resourcing it is to store the data, how costly it is for you to store it, to query it. Also management of the data. You have, when you're ingesting lots of metrics, you have cardinality issues, that affect, this is how many different series, for example, for a specific metric there are based on the different combinations of tags. So managing that so the performance remains correct is something important. So that's where metric storage is going to differentiate. There is an area, potential area for differentiation there, which is traditionally a storage system have been siloed. So you have had a storage system for metrics, one for logs, one for traces. And that made sense in an environment where the instrumentation was different. It was typically associated to the individual tools. And metadata that was associated to those different telemetry was different. So it was hard to correlate them. You could, but you had to do manual work to be able to correlate it. OpenTelemetry is changing that, because now all the telemetry, metrics, logs, and traces, and maybe other types in the future that get added to the standard, are stamped with the same metadata. So you can correlate it. But the problem is that if you're sending that data to different storage systems, then okay, how do you correlate that? You have to build a layer maybe on the front end to collect the information and then correlate it. So there is an opportunity potentially to build this storage layers that are more flexible and sophisticated, that help you store and query all the different telemetry data types, as well as correlate them between them based on the same tags that are used across metrics, logs, and traces.
That's interesting. It sounds as if we are going in a way back and forth, because a while ago it was popular to have one storage for logs, metrics, traces, and then we moved into having different tools for each of those types of data. If I understood right, you're saying that now we are having opportunity to go back to have one storage for all of them, right?
In the past, I don't know myself that there were solutions that were capable of doing metrics, traces, and logs. I know that Elastic uses Elastic. I know is one example where you can put all of that, but it's a bit weird because Elastic can do a lot of different things, and so it does some things better than others. I don't know that. And then querying the data is sometimes a bit complex. But in general, if you look in the past, a few years ago, there weren't tracing solutions because tracing itself was not tracing, as in distributed tracing, was not a thing because people were building monoliths, so the distributed trace was not as useful. And for metrics and logs, people had different systems. Typically, Elastic Sedge for logs, and for metrics they would use something maybe like Graphite, or maybe even back in the day something like an Agios, that would collect some metrics and maybe some events and do something, right? But typically the solutions were independent. You didn't generally have a solution that would do metrics and logs in one single solution, especially a single data layer.
I was thinking now, actually, when I said that, I was thinking on Elastic, which kind of unified all that. But my understanding that the problem, and I'm guessing that that's changing with OpenTelemetry. The problem before was that you cannot effectively store, logs and metrics in the same place because they're very different data types, right? But if I understood right, what you're saying now with OpenTelemetry, we are having this. Everything is time series. There is no real differentiation anymore on the type of the data, hence the type of the storage or the database where you're storing them.
Yeah, no, not really. So the data types, they are still different. A metric and a log are fundamentally different. The metric, typically, you have a value, let's say a float, for example, in the case of primitive, and then a set of tags associated to it. Whereas and it's something, it's easy to aggregate and process. Whereas logs, they're typically signal, one-off events, and so there is typically, a long text that explains, what happened, and potentially some tags. They tend to be less structured than metrics. Although, more recently people are more focused on giving more structure to logs, so they're easier to analyze. But I don't think there is a fundamental difference there. I think the main difference is that the metadata, so the tags or labels that get associated to metrics and logs, will be consistent because they're coming from the same instrumentation, whereas before they would be different. Simple example is that if you're using Prometheus to monitor your Kubernetes cluster, and then you're also running some log collector to extract, or log agent to extract logs and send them, to a logging solution. The way they name maybe container ID or pod ID or the image name, there may actually be differences in how those labels are named. So then when you try to correlate the data, it's hard, because you need to handle the fact that there are differences in how those labels are named. So you need to maintain some mapping, between the two. If you're adding custom tags or labels, you have to add them twice. You have to add them, in your metrics or your Prometheus instrumentation, but also in your logs. And that makes it also difficult, to make sure that to ensure consistency. With OpenTelemetry, that doesn't happen because it's the same library. So when you apply a set of tags, those get applied to all the telemetry that is generated from that component. And so that's the thing that is differentiating, that it's a lot easier to correlate that data than it used to be.
So where do you correlate the data then? If it's, let's say, if you have different storages or databases for metrics and logs, let's say, do you then collect them? Do you unify those in something like Grafana or something like that? How do you correlate it if it's separately stored?
Yeah, that's exactly what I was saying, right? That if you look at this, the correlation is happening typically on the front end, and you cannot do a lot of, it's harder to do aggregated correlation because you have to probably write custom code on the front end that is reading the data and running that correlation. If you dashboard is where you said, you can do like visual correlation, or you just in one dashboard you have information from different sources and visually you're correlating. But in complex systems like Kubernetes, for example, lots of components, etc., it becomes a lot harder to actually do that type of visual correlation. So you typically need some help to do it. And what vendors do, they build a layer, on top of those databases to build that correlation. But then you're somewhat limited to whatever correlations they have decided to implement, right? It's not like you can come, okay, I want to run this other query to correlate data this way. Well, you can't unless maybe you build some code, extract the data, and then correlate it. If you have all the data in one place and with a query language that is powerful enough to do joins and subqueries and things like that, then you can do correlations. At least, this is how I see myself, the problem based on my experience, And that's sort of the problem, that we're trying to solve in Timescale. So we have a Timescale DB, like a database behind where it's a relational database with support for time series. So we can store, it's flexible. We still need to do some work, but it's flexible. It allows us to store different telemetry, different data types. And then you can use SQL, full SQL to run queries and correlate the data. And I think OpenTelemetry creates that opportunity for different types of storages, where that offer more flexibility to correlate the information.
So how would you describe Timescale? So it's not replacing Prometheus, right? It is aggregating data. And I might be now saying something completely wrong, right? I haven't used it yet. Would Timescale DB be the place where all the data is gathered from, or?
Timescale DB, the only thing, it's just Postgres for time series. So what Timescale DB is actually an extension to Postgres. So you run vanilla Postgres, you put the Timescale DB extension. Postgres has this extension mechanism. And by adding that extension, you're adding powerful capabilities to manage time series data. Things like, partitioning the data for improved performance, hyper functions, we call them, that allow you to do analysis on the data, on that time series data, like let's say percentile aggregations and things like that, compression of the data as well. So it does a number of things that will make using Postgres for time series a lot easier, a lot more performant. PromScale is a product that builds on top of Timescale DB. And what PromScale provides is we call it the PromScale connector, is a gateway between observability data and Timescale DB. So you can send Prometheus data, you can send OpenTelemetry data, and it will transform it and automatically generate a schema within Timescale DB Postgres to store that data. It gives you the ability to query that data using PromQL, the Prometheus query language, and it has full compatibility with it. But then you still have Timescale DB, you still have a SQL database, so you can go in there and run basically any query. Like, I've been amazed because I come from an observability background. And the databases that we're using, New Relic has a very powerful database, okay? Cloud database called NRDB, the New Relic database. But the query language that you have, although it provides, good functions for time series data, it's not full SQL. You cannot do joins, for example. Or do sometimes simple things like processing strings, that are returned, so you can present them in certain ways. Whereas with SQL, you can do anything. Basically, it's amazing. I'm not a SQL expert, but I'm amazed by the kind of things that the team, my team is doing with SQL, because they built crazy queries. One of the queries the team recently built on tracing data, for example, is building a map of all the downstream calls. So it analyzes, traces data, and it does a recursive query that is, query that sort of calls itself. I didn't know that was something that was possible in SQL, to build a map that you can see in Grafana of all the downstream or upstream calls from a specific service operation. So that gives you a lot of understanding, okay, from that point in time, let's say you have a service that is receiving a lot of requests. So by running that query, you can get very quickly, you have two drop-downs, get a map, and we use beautiful Grafana capabilities for generating this node graph that will tell you which of the services is generating the increase in request, in the service that you're analyzing. You know that there has been an increase, but you don't know where that's coming from. So that map quickly helps you reason about, okay, what is the problem? Okay, I see that the increase happened here. And then you can go and dig into the details of that service to understand, what happened. You can start analyzing maybe the request that went to that service, and maybe there is a tag in those, in the instrumentation, the traces that you're collecting from that service that tells you there is a specific customer. You see, when you analyze the data, you see there is a specific customer that all of a sudden started making a lot more requests. And so that's how you can use tracing and SQL, for example, like a powerful language that allows you to query the data to find problems in your systems much faster, without, having to guess and do a lot of manual or visual correlation. You can actually use the query language to do that for you.
So if somebody's wanting to get started, you said earlier New Relic was using auto instrumentation, but Datadog, New Relic, App Dynamics, all those. You give it a jar if you were a Java person and auto instruments everything, which is a great thing and a horrible thing all at the same time. So as library maintainers are starting to add OpenTelemetry or whatever to their thing, what can I expect? What should I expect as an application developer using those libraries? It seems like we're shifting everything left. So if we can make metrics and traces and logs just baked in for us, why would I not do that?
Yeah, so two things. So today, obviously, people are using already today a lot of libraries and frameworks. And those have not been instrumented, in some cases, previous versions, of those libraries and frameworks. And those have not been instrumented with OpenTelemetry yet. So the OpenTelemetry project does provide auto instrumentation as well, like New Relic, Datadog, Dynatrace, all those vendors do. So you can actually, to get started, it's easy to get started because you can use that and not change your code, especially for languages where that is possible. Okay, it's not possible for a language like C or Go, but for those that allow for, dynamic injection of code, you can do that. And so that will be like the starting point, I'd say today. You start with those libraries that starts giving you some instrumentation. And then you as an application developer, you build on top of that, and you can start adding manual instrumentation where you see you have there are maybe some gaps and you need more details on how the application is performing. Now, as a framework or library developer, I think it's in your best interest to start looking at OpenTelemetry and start thinking of embedding it. Why? I think I alluded to this before. As instrumentation shifts left, as you were mentioning, Darren, it will become a criteria when evaluating different frameworks to use. So if you have to pick between different frameworks, would you pick one that is not instrumented and move that with that to production? Or will you pick one that is actually well instrumented and gives you good visibility and confidence, to put it in production and ensure that if there is a problem, you'll be able to troubleshoot and understand where the problem is coming from? Think about testing. Will you actually use a framework or library that has no unit tests at all or no testing at all? Will you do that today? Or is that a criteria for you? Okay, no, I want to make sure that there are some tests that ensure that the library and framework is behaving correctly, and as that new versions are released, that there is some regression testing to make sure that it's working as expected and not adding new bugs or breaking. I think it'll become, over time, I expect this will become like a checkbox. It's something that needs to be part of a library or framework for engineers to adopt it.
How far away do you think we are from that?
That's going to take a few years, I think. We're still early, in the process. That's not going to happen overnight. But we're starting seeing in the community, like Kubernetes, I think the GraphQL server as well, they're adding, instrumentation into their code so that engineers, have more confidence running those components in production. And especially if they have a problem, they can troubleshoot them more easily. But yeah, this is going to take, years for sure to get to a point where there is, a lot of coverage across many frameworks.
But I'm guessing it's, and I might be wrong, right? Are we getting to the place where most of the new stuff coming out is already instrumented, and the real trouble is willingness to instrument or provide OpenTelemetry for the things that already exist for many years?
No, I think, yeah. So no, we are not at a point where new versions of frameworks are instrumented by the developers of those frameworks themselves. We're not there yet. I think the project still needs to evolve. For example, adding support for metrics in the different SDKs. So people can use it. At the moment, it only has tracing support. So adding support for metrics will be important. I think logs will also be another important piece. So the project needs to continue to mature. But yeah, we're not at a point where every software developer that is creating a new version of their library or framework, or maybe creating a new one, are adding OpenTelemetry instrumentation. We're not yet there, but we're starting to see some people starting doing that. And I think as momentum on OpenTelemetry builds up and it becomes a key requirement, for people adopting frameworks and libraries, more and more engineers will think about adding instrumentation into their libraries. It'll become a practice. I think the other thing that to keep in mind is that I think for people building not necessarily frameworks, but maybe just applications or services to use themselves, they'll probably just, as they work and write the same way today, they already write typically unit tests for that. They will also add instrumentation using OpenTelemetry. And so that built a habit, it will become a habit to add instrumentation into your code, which was not possible before because the only way to do that in a comprehensive way required to log you down to a specific format or solution. OpenTelemetry, the important thing I didn't mention, but one of the great things about OpenTelemetry is you instrument it, but then you can send the data anywhere you want. It's compatible with anything. It has this concept of exporters. So you can send the data to many different backends, and they may be observability backends, or they may be other types of backends. You could put the data in a Kafka topic, for example, and then there's some other system that reads that data and does something with it. You could send the data to maybe data analytics solution, for maybe not real-time kind of analysis, but more like trying to derive some insights that help you maybe reduce cost, of your infrastructure. And so I think as more and more people adopt that mentality that, instrumentation is important, and the fact that OpenTelemetry doesn't lock you to any particular backend or solution, observability solution or data analytics backend, there is a lot more willingness to add that instrumentation, both for library framework developers as well as people just developing their applications. And eventually will become just a habit to add instrumentation, and people will use a standard that lets them use that data anywhere, which is OpenTelemetry.
What is a bigger problem right now? Is it awareness or the volume of work? How hard would it be for me to instrument my code with OpenTelemetry?
The SDK, I think there is some awareness, still a problem going on, try to, understanding how this works. There is, as I said, a maturity process for the standard, getting it even more mature and adding support for all the different telemetry data types in the libraries that are provided for manual instrumentation as well. In terms of how complex it is, it requires you loading, the different instrumentation, OpenTelemetry instrumentation libraries in your application code, and then is adding lines of code to say, okay, this is the beginning of a span. I mean, I'm getting into terminology, but the trace is broken up into spans, which are different operations. And so you will say, okay, this is where a span starts and where a span ends, which is, when an operation starts and when an operation ends. And it's just, it's just adding maybe a couple of lines of code to do that. Adding metrics is sort of the same. You just, whenever you want to collect a metric, it's the same thing. You just need to add a line of code to add and start collecting that metric. It's not a lot of effort, but if you have a very large application and you need to go in and instrument everything, that is a ton of effort for sure. So it's better to start thinking about it as you start writing the code. But yeah, I mean, for frameworks that exist, that release new versions, instrumenting all the code, there will be, some significant initial effort that needs to be put in to instrument all the different classes, objects, functions.
So if people haven't started with OpenTelemetry yet, it sounds like your recommendation is at least start understanding what it is. It is an open standard, unlike the past decades worth of time where everything was a vendor at a time. That's the reason why I think a lot of people just didn't instrument is, okay, well, I'm doing this for vendor X right now, and I know that a vendor normally has 12 to 18 months life cycle in this company, and we're going to have to do it all over again. If you do OpenTelemetry, now it doesn't matter. Let your vendors change. You've got the data captured in whatever form it is.
Yeah, that's exactly right. Yeah.
If people are wanting to get started, they can do it. Take a look at OpenTelemetry.io, see if your language is supported. I mean, .NET, Go, Java, JavaScript even. I can't believe I just said that out loud. PHP, even worse than JavaScript. All can be instrumented with OpenTelemetry. And then take a look at the collectors. Collectors, right? That's the word I was looking for. It's all based on collectors.
So there is a separate, so it's the, so I don't know what you're trying to refer to. So you have the SDK libraries, then from the libraries themselves, where you instrument your code, you can use exporters to send the data to different places. But there is a component, a very special component, very interesting one in the OpenTelemetry world called the OpenTelemetry collector. And what the OpenTelemetry collector does, it allows you to collect telemetry from many different formats through receivers, then process it. So one example of a processing of processing the data would be downsampling the data, as an example. So you don't send all the traces, but just as a sample of those for cost reasons, typically, because you have to store them, etc., which involves cost. And then a number of exporters to send the data to multiple backends. So again, you can either send data directly from the libraries to different backends, assuming there is an exporter for that particular language that was built in the backend that you're looking, or, which is the most typical scenario and where people are mostly concentrated their efforts, you send the data to the exporter and then you have lots of different exporters, so you can send the data to many different backends.
And this is going to be a softball. What's your favorite exporter? At least I thought that was going to be a softball.
Yeah, I don't know. I mean, by personal, the one that I really like, and the thing that I actually really like about OpenTelemetry, another thing another thing there I didn't mention, I actually like the OTLP exporter, which is the OpenTelemetry Protocol Exporter. So OpenTelemetry also defines a protocol, which means that you don't need necessarily, I mean, if you're building a solution, you can make your solution compatible with OpenTelemetry without building exporter for your specific backend. You can just build an endpoint that understands the OpenTelemetry protocol, and then anybody using OpenTelemetry without having to use some special exporter that you provide can send the data to you. And that is actually, I think, very powerful because it makes interoperability even easier. You don't need to ask people to deploy new maybe components that you provide. They can just rely purely on what the OpenTelemetry project provides to send data to your backend, assuming you add native support for the OpenTelemetry protocol.
So as a vendor, it seems like you would want to just support the protocol and be done with it and say, hey, you want it to ship to us, just follow this path. Nothing special about us. You just follow what the standard is, and we're taking care of writing on the backside of the standard.
Yeah, that is correct. That's what I think is probably going to be the most common approach to this, is having native OpenTelemetry protocol support in the backend, so you don't have to mess with special exporters, especially for observability tools. Obviously, you want to send the data to something that is not tied to the observability world. They probably won't offer an OTLP endpoint, because that's not their focus. But in that case, you can still, maybe the community, builds an exporter so you can send data to that backend. An example, I mentioned Kafka could be an example. Maybe let's say a Tableau, for example, could be, another example. Maybe a relational database, could be another example.
And if people were wanting to use a relational database, what is the best one for them to use for this? This is the real softball, I think.
Yeah, I don't think at the moment.
Hint, hint. Isn't it Timescale?
Well, so I'm trying. I'm trying to answer the generic. I'm trying to answer broadly. I don't know. We could actually check if there is any exporter for relational databases. If there is one for MySQL. I don't believe anybody has built those. If you want to use a relational database, we do provide. You can use PromScale, and then you could use Postgres, which is very obviously very popular open source database. You could use PromScale, Timescale DB built on top of Postgres, and PromScale to get your data into a relational database. So then you can do all the lovely things that you can do with a relational database. SQL queries, joins, aggregations, lots of things, data analysis.
Okay, so if people wanted to get in touch with you or find out more about Timescale, what's the best way to do that?
Yeah, so the best way to get in touch with us, we have a Slack community, timescaledb.slack.com, and there is a channel there called PromScale. that we monitor regularly. So our community hangs out there. We and we interact. We used to typically interact via Slack. That's our main way to interact with the community. And you can find me there as well. So I'm Ramon in that Slack community. You can find me and send me a direct message if you want.
Okay. And we'll also have all that information down in the show notes. Ramon, thanks for joining us today.
Thank you so much for having me.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.